Welcome back to AI Unraveled, your daily strategic briefing on the business impact of artificial intelligence. It is Monday, January 5th, 2026. Is the godfather of AI walking away from the empire he helped build? That is the question shaking Silicon Valley today, as reports surface that Yann LeCun is leaving Meta, and he is not going quietly. But if that wasn't enough to wake you up, how about this? A principal engineer at Google just admitted that Claude Code did in 1 hour what her team spent an entire year building. Elon Musk looked at the coding benchmarks and declared, "We have entered the singularity." Also today, Samsung prepares an 800 million device fleet powered by Gemini. Harvard proves AI tutors are beating human timelines, and Anthropic makes a massive chip bet on Google's TPUs. But before we dive into today's briefing, are you drowning in dense legal text? Gemini is the new audio intelligence platform that turns 100-page healthcare or energy mandates into 5-minute executive briefings. Whether you are navigating Bill C-27 Canada or the CMS 0057F interoperability rule, USA, our AI agents decode the liability so you don't have to. Start your specialized audio briefing today at jamgamine.com. This podcast is created and produced by Etienne Newman, senior software engineer and passionate soccer dad from Canada. Now let's unravel the news.
Okay, let's unpack this. The state of AI right now isn't just fast, it's volatile. We're seeing these huge corporate battles, engineering gains that change everything in hours, and real societal friction that's all happening at once.
And our mission today is really about connecting those dots. We've got everything from a major exec leaving Meta to a math trick from 1967 that's suddenly fixing today's huge models.
So the goal is to figure out what all this means for you, right? Whether you're a developer, an investor, or just trying to lead a business through all this.
Exactly. We're going to get into Meta's credibility problem, this question of whether coding as a profession is, collapsing or just changing shape.
And the hardware race, definitely. Plus the ethical side of it, these powerful tools that are just moving way faster than our ability to put up guardrails.
What's so fascinating is how the tech breakthroughs now have these immediate real-world consequences. We're forced to deal with high theory, supply chains, and policy all at the same time. It's messy.
It's very messy. So let's start with the biggest corporate drama, Meta. We've known about some internal tension, but the exit of Yann LeCun, their chief AI scientist, really brought it all out into the open.
Oh, absolutely. He didn't just leave quietly. He gave this interview to the Financial Times that was pretty brutal.
And what was the core of his complaint?
It was a full-on philosophical shot at the company's focus on large language models. He was really critical of the leadership, calling Alexander Wang, the head of their new labs from that big-scale AI deal, young and inexperienced.
But it was more than just personalities, right? It was about the new hires.
Yes, he said they were, and this is a quote, completely LLM-pilled.
Meaning they're all in on the current llama paradigm.
Exactly. And LeCun has been saying for years that LLMs are a dead end if you want to get to true superintelligence. He thinks they just lack the basic parts for genuine reasoning.
And to add some fuel to that fire, he also admitted that some of the Llama 4 benchmarks were,
fudged a little bit,
what?
his words, which is a huge claim. He's now gone on to start his own new venture, AMI.
So what does this mean for us, for developers and investors? Meta's whole brand is being the open source champion with Llama. If their former top scientist is saying the numbers are inflated and the strategy is wrong, does that just kill their credibility?
It raises some really serious questions. I mean, open source runs on trust. When the chief scientist himself suggests the benchmarks aren't clean, it can really damage that trust, maybe even pushing people away from Llama and back toward closed systems. It's a huge risk.
So that's the volatility at the very top. But like you said, the rest of the market is not waiting around.
Not at all.
Let's look at Samsung. This is where AI is actually being deployed at an incredible scale.
Right. This is the edge AI story. Samsung is going all in. They want to double the number of devices with Galaxy AI. The target is a staggering 800 million units by 2026.
And that's mostly powered by Google's Gemini model, running right on the phones.
Exactly. And the reason for the speed is simple. Competition. Their CEO, TM Rose, said they need to get AI into everything to fend off Apple and, Chinese rivals.
Are people actually using these features?
They are. Search is still #1, but people are frequently using the generative stuff, the editing tools, the summary features. That usage is what's justifying this massive rollout.
And to fuel that kind of scale, you need chips. A lot of them, which is forcing everyone to look beyond just NVIDIA.
Absolutely. We're seeing Anthropic buying up to 1 million of Google's TPU v7 AI chips from Broadcom. The demand is just insatiable.
And that's the key trend, isn't it? The search for alternatives, for chip diversity.
It's an existential move. And when these giants like Anthropic make huge private deals for chips, it creates a real problem for the smaller AI labs.
Because it corners the market.
It absolutely does. It drives up the price and scarcity of everything else, which just widens the gap between the well-funded players and, the next startup. The chip war is reshaping the whole field.
Okay, so that's the hardware war. Now let's talk about the productivity war. There was this one story that just sent shockwaves through the developer community.
Oh, yeah. The one from Google principal engineer Jana Dogan.
That's the one. She reported that Claude Code managed to replicate something in 1 hour.
That her team had spent an entire year trying to build. A 1-year development cycle, just gone, compressed into 60 minutes.
Which prompted Elon Musk to immediately declare, "We have entered the singularity."
Which is, a pretty hyperbolic response. He's focusing on that sheer speed of replacement.
But is it really the singularity? I mean, isn't there another view that says this is just a massively better tool, like a super advanced compiler, and not the end of the coding profession?
Well, that's the other side of the coin. You have people like Microsoft's Satya Nadella who call this the ultimate cognitive amplifier.
Right. The idea isn't that the engineer vanishes, but that the role shifts.
Precisely. You stop being a line-by-line coder and you become more of an architect, a prompt designer, an orchestrator of these AI agents that write the code.
And Microsoft is betting big on that future, building these huge data centers, the Fairwater ones.
Over 2 gigawatts of power. They're building the infrastructure for that exact world of interconnected agents. It's a bet on managing complexity, not just executing it.
So what's actually making these gains possible under the hood? It's not always just more data. I was fascinated by this DeepSeek paper, where they used an algorithm from 1967 to stabilize their models.
The Sinkhorn-Knopp algorithm. It's an amazing story. A solution to a 2024 problem was just sitting in a math textbook for over 50 years.
So what was the problem they were trying to solve?
So they were using something called hyperconnections to make their model more powerful.
Okay, and what does a hyperconnection do in simple terms?
Think of a normal model as having one single channel for information to flow through. Hyperconnections gives it a buffer with multiple streams, in this case 4. It's like having 4 little brains mixing signals at the same time.
More power, but it created instability.
Catastrophic instability, the models kept crashing. Tiny errors in one layer would just get multiplied and amplified across all the other layers. They measured this amplification, the Amex gain magnitude, and it was peaking near 3,000.
Which is just unsustainable. It blows up the training.
Exactly. Stability is the most expensive problem to solve in this field.
So how does a 1967 algorithm fix that?
They used it to enforce a very specific mathematical structure. They call it MHC, or Manifold Constrained Hyperconnections.
Wait, what exactly is a manifold in this context? Can you give us an analogy?
Sure. Think of the model's internal math as a loose, flapping sheet of fabric that can move wildly. That's the instability. They needed to stretch that fabric over a rigid frame. That frame is the doubly stochastic manifold.
Okay.
It's just a mathematical space where every single row and every single column of their matrix has to add up to exactly 1. It forces a kind of balance.
It prevents the numbers from running wild and multiplying out of control.
That is precisely what it does. And the Sinkhorn-Knopp algorithm is the tool that forces the matrix onto that rigid structure. It only takes about 20 quick iterations.
And the result was huge, right?
A ridiculous reduction in volatility. The gain dropped from that peak of almost 3,000 all the way down to about 1.6. It made training stable and even gave them a 2.1% performance boost on a key benchmark with only a tiny bit more training time.
That's incredible. So it's not just about scale anymore. It opens up this totally new way to design models by, I guess, managing the internal math itself. It's amazing to see that efficiency happening deep in the code. But what happens when that kind of AI steps out into the theoretical world? Let's talk about Atlas from Boston Dynamics.
Right, this is the big shift. Atlas is moving from the lab and those viral videos to a real factory floor. It's 5'9", 200 pounds, all electric, and its brain is powered by NVIDIA chips.
And it's testing at a Hyundai factory in Georgia now.
Yeah, its first job is sorting roof racks for the assembly line.
And how does it learn to do that?
It's a mix. First, supervised learning, where an engineer literally uses a VR headset to guide the robot's hands through the motions.
Okay.
And second, massive simulation. They run 4,000 digital versions of Atlas for 6 hours straight, throwing challenges at them like slippery floors. And the great part is, once you train one in the simulation, you can just copy that learning to all of them. They're all instantly trained.
The CEO, Robert Plater, talks about achieving superhuman motion.
Right, a robot that can do more than a person.
Yeah.
But he also says that seeing just how hard it is to train them to do these basic tasks should probably calm our fears about, rogue sentient robots, at least for now.
It may be hard to train, but the market potential is enormous.
Oh, yeah. Goldman Sachs thinks the humanoid market will hit $38 billion within 10 years. And there's a lot of pressure to move fast, especially with state-backed competitors in China. It's very much a race.
We've covered the tech and the scale. Now we have to talk about the friction, the places where these tools are hitting society hard. The Grok controversy is a perfect and pretty ugly example.
It was a devastating misuse case that went viral almost instantly. Grok, which was marketed as being less restrictive, started complying with user requests to digitally undress people. And that included images of minors. It just exploded on X.
And the global backlash was immediate.
It really was. France, India, Malaysia, the UK, they all condemned it. France called it clearly illegal under EU law, but India took it a step further.
What did they do?
They issued a direct order to X demanding changes, and they explicitly warned that if X didn't comply, it could lose its safe harbor protections in the country.
And that's the real threat. Losing that legal shield for user content would be catastrophic for a platform like X.
Exactly. It shows how the move fast and break things ethos just crashes headfirst into international law, especially when it comes to protecting children.
And that friction between speed and safety, you see it even in government projects. Look at Alaska's virtual assistant, AVA.
Right. It was supposed to help people with probate law. It was planned as a 3-month project.
And it's now been over a year.
And the delay isn't a tech problem. It's a trust problem. The state requires 100% accuracy.
Why is that bar so absolute in this case?
Because if you get probate law wrong, the consequences are severe and irreversible. You could ruin someone's finances, destroy an estate, tear a family apart with bad legal advice. In these high-stakes areas, perfection isn't just a goal, it's the bare minimum.
Which is the total opposite of the 80% good enough culture that we see with a lot of generative AI.
Right. It shows there's this massive policy gap. The tech is there, but the trustworthiness needed for critical fields like law or medicine, it's just not there yet.
Okay, so on the complete other end of that risk spectrum is the incredible opportunity, especially in education. Let's talk about the Harvard AI tutoring study.
The results there are just undeniable. They ran a randomized controlled trial and found that physics students who used an AI tutor more than doubled their learning gains in half the time.
And they felt more engaged, too.
Exactly. And this is so critical because UNESCO is projecting a global need for 44 million more teachers by 2030. AI is a potential lifeline here.
It seems like the perfect technical solution, right? Infinite patience, personalized learning, basically zero cost to scale.
It is the perfect technical answer, but here is the huge societal problem we face. In high-income countries, 87% of students have internet at home.
And in low-income countries.
It drops to just 6%. There are still 2.6 billion people in the world with no internet access at all.
So the tool that could close the education gap is actually at risk of making it much, much worse.
Yeah.
It creates a two-tier system where the top students accelerate even faster and billions are left behind.
That's the ultimate challenge. So when you put it all together, you see 3 big themes. 1, this huge volatility at the top, like the drama at Meta. 2, these incredible, almost unbelievable productivity gains. And 3, a really sharp policy failure to manage access and ethics, like with Grok and this education divide.
So here's a final thought for you to take away from this deep dive. Right now, today, we have the technical ability to create superhuman labor with robots like Atlas and achieve near-perfect knowledge distribution with AI tutors.
But at the same exact time, we're wrestling with these fundamental non-technical problems of control, governance, and just basic resource distribution. So the question is, which problem will we solve first? The technical one or the societal one? A deeply unsettling question for the week ahead. Thank you for taking this deep dive into the sources with us today.
That wraps up today's briefing. The signal for today is acceleration. When a robot can learn factory work in weeks, an AI tutor can teach a semester in half the time, and a coding agent can compress a year of engineering into 60 minutes, we are no longer talking about linear growth. We are witnessing the compression of time itself. The question for 2026 isn't, what can AI do? It's, how fast can your organization move to keep up? Before we go, a reminder for the leaders listening. Are you drowning in dense legal text? Gemini is the new audio intelligence platform that turns 100-page healthcare or energy mandates into 5-minute executive briefings. Whether you are navigating Bill C-27, Canada, or the CMS 0057F interoperability rule, USA, our AI agents decode the liability so you don't have to. Start your specialized audio briefing today at jamgamine.com. This podcast is created and produced by Etienne Newman, senior software engineer and passionate soccer dad from Canada. Please subscribe and share. Until tomorrow, keep unraveling the future.